Great, thanks. So going straight into the next talk, which is my one, and then we'll maybe have a little break after that. So, hi, my name's Andrew. I work here at GoCardless. I'm principal engineer. And today I'm going to talk to you about how we are driving data quality through data contracts. But before I do my part, I'm going to ask something of you, at least you in the room. I'm going to ask you two questions. You don't need to put your hand up, but just shout out some answers, please. Don't make it awkward. So 2 questions, and then you can relax again, and then I'll carry on my talk. First question is, what's the one thing you need to know when using data? Quality, yeah, where is it? Yeah, quality, it's a good one. Any more? Where it comes from, yeah. Context, good one, yeah. Where's it going? Yeah, what are you doing with it? Any more? Access, yeah. Who owns it? Yeah, that's a good one. Structured, yeah, structured, unstructured, like the kind of what it is, documentation, yep. What are you going to do with it? Yeah, I hope you know that before. But maybe not, maybe you're exploring data. So yeah, we come context, the source, yeah. So online contribution, source of data. Yeah, perfect. Lots of good ones there. Let's see how many I got. I think we got most of them. We mentioned a lot of these ones. I think, for one, I think is most important when I'm looking at data is, do I trust it? And I think this is important whether you're kind of doing the sort of day-to-day, almost mundane sort of data, using data, or whether you're trying to do something that is more like an organizational goal, a business goal. So maybe you're trying to build, I don't know, a chat interface or something on a model. Doesn't matter what you're doing. I think the thing that's most important is, do you trust the data? So to give a small example, like the other day, I was looking at the BigQuery audit logs, trying to work out how we're using BigQuery, how much I'm spending, things like that. But the audit logs, I'm sure they're complete, but they're not very well documented. They're not very easy to use. They're very nested. So I come up with quite a big SQL, ran it, got some results back. I was like, I don't know if I can trust this data. I don't know if it's really telling me what I want. So therefore, I couldn't use it to make the decision I wanted to make on whether we could save money by doing something else. So essentially, it was useless. That data was of no use to me. So I think trust is the most important thing, or certainly one of them. Next question, and then I'll leave you alone, is, do you trust your data? And you can just raise your hand if you do. Yeah. I was going to say, if you do, come up here next time and tell us how. I think that is a big problem, right, in our data industry. It's like, we either use data we don't really trust that much, we provide data to our people and they don't trust it, or we don't trust it. And then I think if you don't trust your data, it has no value. So that's not great. So how can we gain some more trust in our data pipelines? Well, when you think about trust, the customer has to trust the data product they're being given. But that trust kind of earned throughout pipeline, right? So if you're building a data product, it could be a dashboard, could be a model, could be something else. You're kind of relying on maybe an ETL pipeline, and you need to know what to expect from that. Is it correct? Is it available? Who's looking after it? But they can only provide that kind of level of availability that the source data provides, or that kind of level of correctness of the source data. They can't do any better than that. That's kind of the minimum they can, or maximum they can do. So I think when you look at it like this, I think you could probably say that trusting data starts at the source of the data. So if that's true, then where does data come from? So this is kind of what the architecture looked like at GoCardless a couple of years ago. It's probably going to be very similar to what you've got, unless you're advanced like Dojo and you've got a data mesh. Keep that in mind. We might come back to that later. But for mere mortals, this is kind of what the kind of a typical architecture looked like when you're building them sort of in the last sort of 5 or so years. You might have some services, they write data to their own databases. You then just suck that data into, in our case, BigQuery or Snowflake or whatever you're using. using some sort of ELT process, raising CDC or change like capture, doesn't really matter. You chuck that in, and what you end up with, at least logically, is something like an operational data store. So what you do is you recreate the databases from in that data store in BigQuery. What you have there is a replica of the databases. Same structure, same schema, same data, same everything. You then have probably quite a lot of ETL and DBT trying to transform that data into something useful. And that logically comes with a data warehouse. Might still be in BigQuery as for us, or in Snowflake, or whatever you're using. But that subset of data, that's what you're using to do your analytics, your models, that's where you're getting value from. The rest of it, you're not really. So this is the kind of architecture, yeah, probably familiar to many of you. And I think the problems will also be somewhat familiar. One of them is the classic, in that changes upstream negatively impact users downstream. So schema changes, obviously, can break things quite loudly. Logic changes maybe less loudly. Any kind of evolution of that data can negatively impact people downstream. Another problem with this architecture is we've got this big bottleneck in the middle. So although the data in the operational data store is, in theory, it's accessible, it's in BigQuery, you can use SQL to access it, you can use Looker to access it, whatever you're using, it's not that usable. To use it, you need to know a lot about the upstream service, how it models the world, why it does it in a certain way, how it's evolved over time. Unless you've got that context, it's not really useful to you. The only data that's useful to the majority of people in business is the data that's gone through a BI layer of some description. So some BI people have transformed that, or data engineers have transformed that into a data warehouse, and that's the only data that's really of use. And the third problem is you've got this massive gap between the generators and consumers. The data generators probably don't even think they're data generators. They just work on their service, delivering features, make changes to the databases. That's kind of, that's good, that's what they're doing. But I don't really know what's going on beyond that. They might not even know there's some ELT process sucking that data out. They certainly don't know what value you get from data later on. Data consumers, they're just kind of getting what they're given, but don't really have the opportunity to ask for better or more. They often have to infer things in the ETL layer, often have to work around things, which typically is another case statement, another if this, do that, else do this, another if date less than today, do this, otherwise do that. All those kind of workarounds. The problem is you keep doing those workarounds, keep trying to infer things that aren't really clear in the data, you're further increasing complexity of ETL, and that further increases the unreliability of your ETL. I think the root cause of these problems is that the data we're using was not built for consumption. It's not built to be built on. It was built to model data for the service, built for a transactional database, not built for what we're trying to do with it. So is there a better way to do this? What is it we want? Well, I think we want data that is documented, it's usable, it's accessible. We want data that's versioned. Data can evolve over time, that's fine. But an evolution of data shouldn't break everything downstream. That's not so good. If you want clear expectations on the data, like that previous diagram I showed, you need to know what the expectations have been provided so that you can build on it with confidence. And then we also asserted that this really is the responsibility of data generators. Only they have full context of the data, only they have the ability to change the data and improve the data. It's their data, ultimately. Nothing we can do downstream can improve the quality of data, really. It's kind of bound by that. Nothing we can do downstream can fill in data that's missing, that's incomplete. The only place you can do those sort of things is at the source. So this starting to sound a bit like an API. So my career, first half of it was more software engineering, and second half kind of accidentally ended up in more data engineering or data infrastructure. As a software engineer, if I want some data from another service, I wouldn't say, can I have access to your database, please? Because I'll say no. I'll talk to that team, I'll say, hey, I need some access to the data you're generating. You can provide an API, we have a little chat about it, agree on some sort of interface. They'll build an API quite quickly because building APIs is quite easy these days in modern frameworks. And then I'll consume that API and go about my work. Not too hard. Why is it different for data? I'm not sure it should be. I think for data, we want the same sort of things. I think we want an explicit interface that's been agreed by their generous consumers, something we can build on. We want something that's fairly stable, but the ability to evolve over time. And when people talk about an API, they often say it's like a contract between the provider and the consumer. And this word contract kind of stuck with me, and that's why we called it data contracts. Yeah, so that's the problems we're trying to solve with data contracts. That's kind of how we arrived at this idea. Next session, I'm going to talk more about like what are data contracts. And I've been trying to evolve this description over the last sort of few years, really. I think it comes down to kind of 4 principles. So first off, a definition. This is kind of, again, I've been evolving this over a little while. But I'll say a data contract is an agreed interface between the generators of data and its consumers, sets expectations, like I already mentioned, defines how it should be governed, because governance is optional, and facilitates explicit generation of quality data that meets requirements. And those 4 highlighted words, I think they're the 4 key parts, the 4 principles of data contracts. So we'll go through each of those in turn, just briefly. So interface, I've already spoken quite a lot about interfaces, really. I think interfaces are key whenever you're trying to depend on something, but particularly in distributed systems, but just any dependency. Right, if you're using pandas or any sort of library, you're building on that interface, and it will, if they make changes and it breaks, there'll be a new version. Same if you're using an API, same if you're using data. So we want a stable, supported interface. We want it versioned. And this interface kind of forms the basis of an agreement between the generator and consumer. And kind of like I mentioned in the API example earlier, this is where you can sort of encourage some collaboration between those 2 groups of people, those consumers and generators. It gives you something to talk around. Second one, expectations. Again, like I mentioned this already, but this includes things like documentation, SLOs, how reliable is the data, and also helps define the ownership and responsibilities of that data. I think these expectations are really key if you want to build on that interface with any confidence. Governance, always got a bit of a bad reputation, but I think it's not really optional these days. And the good news is video governance is that you can automate a lot of it away. As long as you collect some metadata around data, understand the data, some context, it's not that hard to build some tooling that does things like expires data when it passes the retention period, perform GDPR deletions, things like that. And we can define some of that through a data contract, which I'll show in a little bit. And finally, explicitness. So trying to move away from the idea of like just sucking in data that wasn't built for consumption, trying to explicitly provide data that's built for consumption that meets a requirement. Data products, if you like Emmanuel spoke about earlier, data products that meet business requirements. But for generators to do this, they need to know like why they're doing it. So there's a bit of a 2-way street going on between those consuming data as well. Like, I imagine most of you are more on the consumer side. You as data consumers need to be able to articulate the value your business is getting from the data. And if you could do that, you'll find your data generators are they're more incentivized to go and help you out on that. Kind of more of a partnership rather than being so far apart. So I think they're the kind of 4 principles that make up data contracts. Certainly 4 principles we're trying to follow here and trying to implement here. And it sounds like we're asking data generators to do more, and we are. But they're not in the room, so, but it's not necessarily that hard. We want to make it easy for data generators to do this. much like creating an API. That's quite easy. And that's what we're trying to do at GoCardless. So next, I'm going to talk a bit about how we've implemented data contracts at GoCardless. Some of it is quite specific to us and kind of what we had available, kind of the infrastructure platform we built it on. So I wouldn't worry too much about the specifics, but hopefully by showing it, you'll kind of get an idea of like what it looks like and how it solves the problems I mentioned earlier. So this is kind of a start of data contract. It's got a name, description, owner, version. We define it in something called JSONet, which is like JSON with extensions. Again, that's not necessarily the best way to do data contracts. It's just we built it on an infrastructure platform that uses JSONet throughout, and it's the obvious choice. But yeah, main thing is we've got name, description, owner, version. We then have a number of fields for schemas, has a name, description, type, as you'd expect. Also some other metadata around, is it personal data or not? How do you normalize it? When we should get rid of it? Those kind of things. And it's through this kind of metadata that allows you to build the tooling to go and automate data governance away and do many other things as well. Yeah, as long as you have the kind of metadata, the right context of the data, it doesn't really matter how data is structured. You can always ingest it and process it using some fairly simple tooling, really. And finally, we asked the data generators to tell us what resources they want or what services they want to support the data. So they want PubSub, we're using Google Cloud, so they want PubSub, they want BigQuery, they configure that if they need to. And this is interesting for two reasons. One, it's how we think we're going to deploy or how we will deploy kind of any data tooling we build into a business. So in future, we could do things like automatically measure SLOs for them and report and send alerts and things like that. We could automatically refresh data assets. We could integrate with third-party services like Salesforce or whatever through like a reverse ETL tool. Whatever we want to do in sort of data to support our data generators or to support moving data around, we think we can deliver through data contracts. But the second reason this is interesting, I think, is by giving data generators this kind of flexibility, we're increasing their sense of ownership and their sense of autonomy. So we're not saying you have to use BigQuery. Like if the best way for you to provide data to consumers is via PubSub, be more event-driven, that's fine. We trust you to make the right decision for the use case you're trying to solve for your data product. If you want to structure a schema to be really wide or really deep and really nested, that's fine too. We don't really care. Just make sure you label it with metadata so our tooling can work with it. And this kind of, it's little things really, but it gives the data generator a greater sense of ownership, a greater sense of autonomy. Like it's your data contract, it's your data, your control, but your consumers as well. It's the kind of product you're delivering for them. What we end up with, that's all we have to do to generate a data contract is something like that. They merge it to a Git repo, to main or master branch. If I could do that, there's no sign-off from a central team. Again, promoting that autonomy. And once it's merged, a few things happen. We generate their resources they asked for, PubSub, BigQuery. They have schemas attached to them. Those schemas are always in sync with data contract, even as data contract evolves. So we can guarantee to be correct. But the kind of interface that you're providing to your consumers. We deploy a number of services. These might be cloud services or might be Kubernetes services kind of in their namespace, in their area, to help them manage that data. So data handling will be kind of data governance side and things like that. All of these are their resources, their services in their Google Cloud project, in their Kubernetes area. It's theirs. They get ownership of it. But the data, although it's kind of isolated in these Google projects, it's not siloed. We don't want to silo data. So we populate some central services too, a data catalog, so it can be discovered, metrics, dashboards, alerts, things like that. And because we're using BigQuery and something like Snowflake's the same, although we've separated things and isolated things in different projects to promote ownership and to prevent kind of one data set affecting another data set and things like that, it's not siloed. You can always query in BigQuery or in PubSub or in Snowflake. You can always go across projects. There's no penalty. There's no performance penalty. There's nothing. There's basically one BigQuery we're all sharing. So although it's isolated, it's not siloed. It's still available to everyone who wants it. And then at a higher level, we end up with something that looks a bit more like that, like this. So every service has its own kind of area and data warehouse. These are basically data products that Manuel was talking about earlier. So each of these data products, they should be useful on their own. So if I'm a product team and I'm producing data that's useful for finance, for some finance process, I can just generate and provide it to them. They're my data consumers. I don't need to go through a BI layer for that, or BI engineers or anything like that. I could provide that directly to them. Also, we still have BI, we still have ETL. There'll be more generating data across different domains, across different products, again, like Manuel was saying. And all of this data can be used for analytics, for models, for services, for whatever we want to use it for. So we've got much greater share responsibility. We've got rid of that bottleneck we had in the middle. Yeah, so a lot more decentralized than it was before. Almost like a data mesh. So that's a very quick run through the implementation. There was a link to a Medium post if you want a bit more on the implementation. But I think with data contracts, it's not all about the implementation, really. In fact, that's quite a small part of it. But the implementation didn't really take us that long to kind of build, at least kind of a proof of concept. It's not particularly difficult, I would say. The reason we're doing data contracts, I think, is to try and change the organization, change the culture of the organization. I want to move away from this kind of ELT style, kind of quality over quantity of just chucking data in and expecting to get value later. We want to start producing data more deliberately as a product feature or as a product, not as a byproduct. We want to encourage collaboration between the generators of data and consumers of data, working a lot more closely together. And I think by doing that, we're going to start moving towards a more of a real data-driven organization that actually does drive business value from quality data, from data they trust. Because we believe, we know our data has value, and we guarantee it with a data contract. And that's all I've got. Thank you very much. There's some more links there. If you really like it, you can buy a book about it. It's coming out soon. Yeah, thanks very much. Any questions? Yeah. Cool, that's a good question. I'll repeat it for people on Zoom who probably haven't heard. So the question was around so is data contracts more for like new data, like new data sources, or can you kind of start applying it to old historical data? That's a really good question because what we're seeing at GoCardless is obviously people are starting to use it for new projects, kind of organic usage, and that's great. Even some quite critical things like we have data sets around sort of banking events, they're choosing to use data contracts, and that's great. We have all this data that's still coming through, we change data capture pipelines, and what we want to do is try and migrate people off that onto data contracts. Obviously, after sort of 6 years of using those pipelines, it's not that easy. People understand benefits, engineers understand benefits when you speak to them. The question is always about prioritization. How does that take preference over other product features? We've tried various techniques to try and encourage migration. You try and turn things off. That tends to force emergency. But we're still working out how best to balance that against other priorities the company has. So, yeah, not necessarily easy, but we do want to do that because ultimately, we have a data infrastructure team supporting this. They're supporting this and the old stuff. we're not going to be able to deliver as much new stuff. We keep supporting the old stuff forever. But this is a problem that every platform foundations style team has. Not many organizations have solved it. Yeah. Mm-hmm. Cool. Okay, great. That's two good questions. First one, the question was like, as a consumer, are you feeling an up-to-date contract? The answer, there's different opinions, I think, of this around the internet, but no, I would say the data generator owns the data contract because ultimately only they are in control of the data they're generating. Like you're not. So say you create a data contract and their data doesn't pass it, what are you going to do then? Like who's going to be incentivized to fix it? You can't do anything about it. There's an area of, again, from software engineering, this idea of like consumer-driven contracts, which can be used kind of for API development and things like that. There's a framework called PACT, PACT.io, I think. That's kind of a consumer-driven framework that could be applied to data contracts too. And there's other solutions like Solar.io, it's kind of more consumer-driven contracts. But I think with all that, you're not really changing the ownership. You're just creating alerts, really. You haven't really changed the ownership. You haven't really moved things upstream, moved things left. So I'll say data contracts have to be owned by the data generators. The second question you had was around analysts sometimes producing a lot of costs from querying data, transforming data, and can data contracts help? That's a good question, and I think yes, it can, because I think what you're doing with data contracts is you're moving some of the this transformation, this ETL you're doing, you're moving it further upstream, be done in the service, where it's a lot cheaper to do. It's a lot cheaper to do it earlier, it's a lot cheaper to do it once, just have one person doing it rather than have BI do it, data science do it, LookML doing it, or whatever else you've got doing it. Also, you can do it more reliably there because people are doing it for people who know most about data. So we do expect this to reduce the amount of ETL we have to do, simplify that a lot, and that will reduce costs as well. No problem. Hey. So the question was about contract testing, whether we have standard tooling. What we do is, so the contract I showed was defining something called JSONet. It's kind of how they define it. But from that, we can generate many different formats, anything we like, really. We do a few at the moment. We do one into protobuf, which is then used to configure PubSub, just happens to be what PubSub uses for schemas. And that then enforces the schema, at least, at PubSub. So you can't write something to PubSub without it matching schema. I guess another one we generate is kind of BigQuery, as like JSON for triggering BigQuery tables. So again, that's kind of enforcing a schema level contract there. You can't write to BigQuery unless it matches a schema. Third one we do is we transform that into into JSON schema. And JSON schema is quite good because you can start defining data level tests in there. So you can define sort of minimum, maximum bounds for a number. You can define a regular expression for a string, or you can say the string has to be an email and that's very built in. So we can start doing data quality checks at generation time. And we want to try and do, with all of these, we want to try and do these checks as early as possible, so at generation time, because then when something goes wrong, it only impacts that service. The owners of that service, the data generators, they get alerted, they can go fix it before the data goes downstream, potentially into many different services, but then all have to go and apply a fix, all have to kind of replay data and those kind of things. So the earlier we can catch that, the better. Yeah, we don't do loads of this testing at the moment, but we'll probably do more in JSON schema and rely on JSON schema and the libraries. In future, we might build our own libraries to go further, but yeah, for now, that's kind of what we got. Yeah, sure.
In your opinion, do you think data warehouse vendors, Snowflake, could do more to natively support their contract, or have you circumvented required?
Yeah, that's a good question. I'll just repeat it for the Zoom. Whether like for your data warehouse vendors like Google, Snowflake, like could do more to implement data contracts at their level. I think some can. So I think we use Google. We're lucky PubSub supports schemas. Not all. I don't think like AWS Kinesis. Don't think that supports schemas. So things like that are missing. Kafka does. I think. I mean, like these vendors have data catalogs, but don't necessarily support data contracts, but they normally support whatever you like, basically, like free tags and things like that. I don't know what they could do more. I think, because I think the tooling is quite simple. I guess like, so what I showed, the way we implement data contracts is at the infrastructure platform level. So there's no reason why Google Cloud or the like or AWS couldn't, I don't know what they're called, but Google Cloud has something called config injector, which configures resources and everything like that couldn't support data contracts natively and do what we're doing to provide the BigQuery table and PubSub and automate all that for us. Same, I guess, for other infrastructure people like Terraform and Pulumi, they could support data contracts natively. But I think really, yeah, data contracts for tooling isn't really that hard, I'd say. So it's not necessarily a big barrier if they're not providing extra help. You can, as long as you've got some sort of infrastructure as code thing, you can probably do data contracts. The harder bit is the culture change around it, I'd say. That's a good question. Any more? Yeah. Yes, good question. So repeat it again. So any tracking in place for services using data contracts and not using data contracts. We have we have a dashboard showing adoption rate, basically, which is kind of like measuring how many queries go through a data contract table as opposed to a change data capture table. We have queries. We know how many PubSub topics are using data contracts as opposed to not. So we track adoption rate, I'll say. Obviously, we're trying to get that higher. Yeah, so that's all we do, basically. Cool. Any more? All right. Shall we take a little break? Yeah, should we take 5 minutes comfort break and be back again for the final talk? Thanks a lot.